Hey, this is Warren Redlick. I'll tell you what, this guy's been busy. He's been building data centers like crazy. He's got a crazy supercomputer coming. I'm going to tell you about that in this video. But a brief history, Elon has built Cortex-1 at Tesla, Cortex-2 at Tesla. He's built Colossus-1, Macro Hard. He's built Macro Harder, an ever-increasing scale of supercomputing clusters for AI. But now what's coming is even bigger, combining Vera Rubin and the SpaceX IPO for capital. And we're going to see the most amazing data center with 10,000 Vera Rubin NVL72 racks containing 720,000 GPUs. It's going to cost in the ballpark of $50 to $75 billion. It'll use HBM4 memory. It'll have gigawatts of power, 800 volt DC architecture working with Drew Baglino's Heron power, efficiency leap with 10x better tokens per watt, lower construction cost, more efficient, be able to deliver massive tokens at massively low cost. Are you ready? Let's go. Where this starts is SpaceX is about to do an IPO. They're going to raise in the ballpark of $80 billion in capital in this IPO. When you look at what people spend when they build AI data centers, you see very, very large costs. Because the next generation data center is going to use Vera Rubin GPUs, that's going to cost more than the existing GB300, GB200s, and so on. I want to break down for you where I think this is going. I see a 10,000 rack supercomputer cluster using Vera Rubin racks containing 720,000 GPUs total. Each rack contains 72 GPUs. This would create the largest single AI cluster ever proposed, the biggest, the fastest, etc. The hardware cost for this is going to be in the ballpark of $50 to $75 billion for the full system. He may get lower end volume pricing from Jensen Huang. He may get a somewhat favorable pricing on memory. The cold hard reality is that there's so much demand for all this stuff, you're not going to get a lot of discounts. But Elon figures out ways of getting things done. I'll go through a couple of ideas I think are going to work to help reduce costs later in this video. But just basically, if you think about the funding model, if SpaceX raises $80 billion from the IPO, and they've said in the IPO that the first thing they listed they were going to spend on was AI compute. And they don't really need to invest that much to advance Starship. They don't really need to invest that much to advance Starlink. That stuff's already ready to go. The CapEx is already there. It's just a matter of building at scale. And Starlink is already generating the revenue to cover those costs. Out of the $80 billion, if they make a deal with Nvidia, Nvidia's been doing deals like this a lot, where they pay Nvidia a certain amount of money in cash, and then they pay them $10 billion in SpaceX stock. And then there's other costs, and it adds up to $70 billion total, minus the $10 billion from Nvidia, so they're out $60 billion in cash. That makes this feasible from a money standpoint, that they can afford to do this. They got to find a location. They got to find other things. They got to find where they're going to get their electricity generation from. They got a lot of issues, but that's all doable. In terms of getting access to the chips, sometimes it's hard to get chips, but Jensen Huang seems to favor Elon due to past Colossus execution speed, personal rapport, mutual strategic benefits, and that might give Elon the access he needs to get those Vera Rubin GPUs in high volume quickly. I don't think they're currently shipping at scale, but they'll be shipping at scale soon. And if the SpaceX IPO closes in, let's say, late June, that gives them plenty of time to get started and get going. And as the Vera Rubin GPUs ramp, they can get started on building this thing out. The power consumption of this thing would not be that bad. You would think, okay, we did a 1 gigawatt data center. We're going to make one that's 10 times as powerful. But because Vera Rubin is so much more efficient, and because of other features we're going to see using 800 volt architecture and so on, it'll make the thing more efficient. You'll get more tokens per watt without having to use that many more watts. You don't need that much more electricity to power this data center because it's so much more efficient at converting power into tokens, into intelligence. You got up to 10x better tokens per watt and 10x lower cost per million tokens as a result compared to the Blackwell GB300, which Elon has said is the best AI chip on the planet today. But Elon's never satisfied. I think one of the biggest cost-saving potentials, not just cost-saving, but getting access to hardware and getting it at a reasonable cost, is Drew Baglino. Drew Baglino was a leader at Tesla, and he's developed a startup called Heron Power that provides solid-state transformers and 800 volt DC conversion systems, modular 4.2 megawatt, offering 70% smaller footprint, 65% lower electrical costs, and rapid deployment. And Drew just posted about this. I want to go through what Drew said because it's critical to the point. We're publishing our vision for how future native 800 volt data centers will be built. Vera Rubin is built for 800 volt. There's plenty of discussion circulating. Our work stands apart in two ways. First, it's an end-to-end blueprint for an AI factory data hall, fully specifying a 12 megawatt building block with bill of materials, redundancy, etc. Line items, the costs and labor breakdowns per megawatt. Stacked against today's tech, Heron's architecture is 1/3 the Nvidia rack cost, 1/10 the installation labor, and half the inefficiency from grid to chip, unlocking faster, more affordable gigascale buildouts. That sounds good. And there's more. There's a post on their website. You can read this. You can check Drew's profile and get a link to it. But you can just see lower Nvidia rack electrical cost, lower Nvidia rack electrical installation labor, 50% lower power delivery losses. Now you're getting even more efficient with the electricity. The chip's more efficient with the electricity, and now the electrical infrastructure is more efficient with the electricity. 25% faster construction schedule. I know a guy who likes building faster. His name's Elon Musk. We know in the past, Elon and his teams have been able to deploy data centers crazy fast, much faster than anybody else. So Elon-style execution could deliver initial racks in a few months post-IPO, phase the full cluster over 6 to 18 months. I bet Elon moves faster than that using prefab on-site generation. Elon just finds ways, whether it's massive solar or it's gas turbines. He built a gas turbine power plant to power Colossus 2. Mega packs on site. Kind of picture Texas, but I don't know where they'll put this, but somewhere where they can get through the regulatory hurdles, find a place that's looking to build out a data center. There's so much resistance to data centers around America, but there's places that want this stuff. Get this going fast, creates massive local jobs, really boosts the local economy for people who are paying attention and understand what's happening. There's strategic integration involved in this. You got deep synergies with xAI, with SpaceX xAI's Grok training and inference. It'd be interesting to see, is there part of this plan to have this integrated not just with xAI and Grok and training inference, selling compute to other companies, like they've sold compute to Anthropic. And now you've got, if your cost is more, but lower on a per token basis, and then you're able to sell it with lower electricity costs to buyers like Anthropic who need this compute. They already have like 80% operating margins on Colossus 1 on the deal with Anthropic. Now you're talking about maybe 85 or 90% margins on whoever your next customer is for this kind of compute. And the demand for compute is going up. So this is a game changer for SpaceX and SpaceX xAI in terms of generating massive revenue, massive profit, so that you can train Grok better. You can build the next data center after this. You can start building the infrastructure for Terafab. If you've got the cash flow rolling and all of a sudden you're generating more and more cash coming in, now all of a sudden you have the cash support to build Terafab. You have the cash support to build out your AI data satellites, which are coming in a couple of years. Like, this is the precursor, right? After this, you start doing satellites in space and they get cheaper electricity. That's when with the D3 chip coming from Terafab. So this might not be the last one on Earth. They're probably going to do a couple more on Earth. And they specifically said in the IPO documents their advantage in building out terrestrial data centers. So they've signaled we're going to be building more data centers on Earth, and then we're going to be building data centers in space. This probably becomes the most capable single AI data center on Earth by a significant margin in 2027 between Vera Rubin, between their speed at developing this, between the intelligence of the team, the competence in knowing how to build out something that's really good, the experience working with Anthropic now to know what customers are going to want out of a data center. So you can operate Grok, you can operate your own AI out of this data center, but you can also you can train even bigger models, Grok 6, Grok 7, who knows? And at the same time, you can serve, whether it's Anthropic or whichever other companies want data center access, you sell it, you make massive profits. On the whole, what does this accomplish for Elon, Team Elon, and society? You accelerate frontier AI because you can train even bigger models even faster. You accelerate robotics. Don't think Tesla is necessarily going to use this for robotics. I think the Cortex 1, Cortex 2 clusters are designed for that. There's probably going to be a Cortex 3 at Tesla that's going to be different. I don't think they need the same volume of compute. They don't necessarily need the same type of compute for that kind of training. And does this even help with multi-planetary goals? If you're generating enough cash flow for SpaceX, it becomes easier to fund all the things you want to do in space. I've been saying for a little while now, SpaceX is no longer a rocket company. They're an AI company that happens to have rockets and satellites. We call them a space company. And that As they deploy AI satellites in space, then they become an AI space company, I guess. Getting electricity generation is going to be a big challenge, but Elon's up to it. Getting the hardware, the electrical infrastructure hardware to build something like this is a challenge, but Drew Baglino's team is up to that, along with Elon's team. You need supply chain prioritization, you need creative financing, and you need Elon speed in developing this. They've got it all. This is coming. We're going to see a spectacular new data center coming, the biggest supercomputer in the history of the world, and it's going to be running these racks, 10,000 of them. Very excited to see this. I hope you're pumped. Now, this is AI Stocks Report channel, and SpaceX will probably become a publicly traded stock in June or July, and people will be able to invest in it. It will become a part of our AI Stocks Report index, and I'll be reporting on it as a publicly traded company instead of where it is now. And as a part of the channel, I do videos on options, long-term call options, and I have a metric for evaluating long-term call options. And the insights that I get from this metric that I share with my audience, this is for YouTube channel members, ex-subscribers, and for Patreon supporters. The insights that we get from that help us understand not just long-term call options, but also understanding long-term investing in AI stocks. So please consider supporting me as an ex-subscriber, as a YouTube channel member, or as a Patreon supporter. Thank you so much for watching.